push that rock here with my 412th take of this video. So if I make a mistake this time, y'all are just going to suffer through. Imagine you write scripts for the Fantastic Four. And you want to know how many choices of two characters from the Fantastic Four are possible. You know, in other words, you're going to write a script and you can just involve two of the characters, not all four. So how many are possible? Well, who are the characters? There's Reed Richards. There's The Thing. There's the Invisible Woman. And there's the Human Torch. So if I'm going to include two of them, I could include Reed with The Thing, Reed with the Invisible Woman, and Reed with the Human Torch. So there's three choices right there, but the Reed doesn't have to be in it. It could be The Thing with the Invisible Woman or The Thing with the Human Torch. But The Thing, so we have The Thing with all three others, but The Thing doesn't have to be in it, so it could just be, see, we've got, so that just leaves the last one as the Invisible Woman. It could be the Invisible Woman with the Human Torch. Okay? So there's six ways to, six choices of two characters from the Fantastic Four to put into this script. So, now we just want to ask that question over and over again. So we already did this one. There's 6 ways to do it, to choose 2 of the Fantastic Four characters. How many choices of 0? In other words, I'll write a script in which none of the Fantastic Four show up. Maybe their support staff are in it, or maybe it's a crossover and it's another villain and another hero from Marvel. Well, there's only one way to do that, and that's to leave them all out. How many choices of 1? Well, there's 4 characters. I could choose Reed, the Invisible Woman, Thing, or the Human Torch. So there's 4 here. How many choices of 3 characters out of the 4 Fantastic Fours? Well, that's the same as this, because it's just how many ways can I leave one out? Well, I can leave Reed out, the Human Torch out, the Invisible Woman out, or the Thing out, and then use the other 3. So there's 4 ways to do that. And then how many choices of using all 4? Well, you got to use all 4. So there's one way to do that. Now, do these numbers look familiar? 1, 4, 6, 4, 1. Yes, that's a row on Pascal's triangle. Now, we need to have some notation. So when we want to talk about the entry that is the kth entry on the nth row, we use this notation here. So the 4th row, the second entry. Why is this the second entry? Remember, this is the 0th entry because you can choose none of the characters. Okay, so 0, 1, 2. Remember, we start by counting by 0 on the Pascal's triangle. So the 0th row, 1st row, 2nd row, 3rd row, 4th row, 0 entry, 1st entry, 2nd entry, 3rd entry, 4th entry. So 4, 2 is equal to 6. That's how that notation works. So let's use, and it turns out that this is also equal to the population size here, which in case we usually use capital N. Oh well, we use K. We could do it like this. So the population size, and then we have sample size. And the question is, how many samples of size lowercase n are possible from a population of uppercase n? Okay, and so you're counting. So this gives us the number that is the kth entry on the nth row, but it also gives us the number of ways to choose 2 items from a set of 4 items. If that makes any sense, okay? So here's an example. I got 6 kids. I have an inheritance. Let's pretend I want to leave my inheritance. I want to split my inheritance evenly with just 3 of them, okay? You know, like I want it to be a meaningful inheritance, so I want to change the life of 3 kids, but if I split it up among 6, well, they'll all just blow it on a car and I haven't changed their life. So I'm just going to share it with 3 of them, and I want to leave it evenly with those 3, though. It'll be enough to actually change their life. Like maybe it's $300,000. So if I shared it evenly with 3, they'd all get $100,000. They could all buy a home with that and change their life. You know, they'd have home security. They wouldn't have to pay a mortgage. It would really change their life. Okay, so how many ways can I do that? Well, the notation is I have 6 kids and I'm going to choose 3. How many ways are possible? How many ways do I do that? Okay, well, you go to the 6th row, okay, and you choose the third entry. So 0th entry, remember you start counting with 0, 1, 2, 3. So it's 20 ways I could do that. Okay? 20 combinations of 3 of my 6 kids. So let's do it with the formula. So here's the formula, and you have to know what factorial means. 0 factorial is just defined to be 1. And then 1 factorial is 1. And any other factorials, all the numbers down to 1 multiplied together. So 2 factorial is 2 times all the whole numbers, I should say. 1 is equal to 2. And 3 factorial is, well, 3 times 2 times 1, so it's equal to 6. And 4 factorial, well, notice I'm going to go 4 times 3 factorial, right? Because I'm going to go 3 times 2 times 1. 3, so it's 4 times 6, which is 24, and so forth and so on. So there's how you do factorial. So here's the factorial. So using the formula, it would be 6 factorial over 3 factorial times 6 minus 3 factorial. Now, I cannot divide 3 factorial into 6 factorial like I can. 3 goes into 6 twice, but 3 factorial does not go into 6 factorial. So be careful about canceling. But I can do this. I can say 6 times 5 times 4 times 3 times 2 times 1. But 3 times 2 times 1 is 3 factorial. So I'll just leave that there. And I have 3 factorial here. And then 6 minus 3 is also 3 factorial. And then I see one of these 3 factorials will cancel with that one. Okay? And then what do we say 3 factorial was? 3 factorial is 6. So 3 factorial is 3 times 2 times 1, which is 6. So I'm left with 5 times 4, which is the answer, 20. So that's how I use the formula. But, you know, we're going to be using the triangle as much as we can unless the numbers get too crazy and the triangle's too hard to build. Math made simple, Cincinnati.